Hello everybody, welcome to my YouTube channel, Coding Fit Trees. Today we are going to solve the longest continuous subarray of absolute difference less than or equal to limit. The problem statement, they have given an array of integers numbers and an integer limit, and we are requested to return the size of the longest non-empty subarray such that the absolute difference between any two elements of this subarray is less than or equal to limit. In example 1, we can see there are two subarrays that satisfy that condition, 2 and 4. And the difference in that case will be 2 minus 4, 2, and the subarray 4 and 7. So in that case, the difference is 3. Among those two subarrays, both has length 2, so the max length will be 2. Let's take this second example and elaborate how to find a solution to this problem. Let's paste it here. It's not copied. So limit in this case is 5, and we have nums array. So to solve this problem, when you can notice, we need the max. We only need to keep track of max and min, since max minus min will always be the highest difference possible in any given array or subarray. So for that purpose, we'll be using dec, but you can also decide to use a data structure like heap, max heap and min heap. But we're using dec since adding and removing in dec will be off1 or constant time. And also, one can notice we can use sliding window to keep track of the subarrays, and those who violate the condition, we can just discard them. So sliding windows. And sliding windows has two pointers. One is right, the other one is left. So we'll keep sliding window. Sorry for my handwriting, it's awful. So we have left and right pointer. Let's denote them have L and R. So you have two decks. One is max deck, let's call it M max D. The other is min D. Let's illustrate how we can find a solution using this method of sliding window. So in the beginning, we'll add it to the deck. This deck will be in a decrementing order, and the min one will be in increasing order. So 10. First of all, you have 10. So 10, 10 will be pushed since the deck is empty in the beginning. But you will also have to check if the current window, which is only has one element, violate the condition or not. If you violate, we'll discard it. Otherwise, we'll keep it. So let's say the min of the window is 10. The max of the window is 10. And the limit is 5. 10 minus 10 is 0, which is less than 5. So the condition holds. We don't do anything. Then we iterate. We move right, but left stay the same. Left is 0 in this case, but right will become 1. Right move to this. So for max, we check the element at the top, which is 10. 10 is not less than 1, so we just push 1. But in case of 10, 10 is less than 1. So we pop 10, and then we push 1. Push 1. Then again, in this case, we'll have to check the max of the window, which is this from 10 to 1, that's 2 elements. The mean is 1, the max is 10. What we'll do here is we check the condition if it satisfies. 10 minus 1 is 9. 9 is greater than 5, so the condition is violated. So in this case, we'll have to discard the window. To discard the window, we'll check if left, which is in this case the value is 10, or the left value is 0 and the value is 10, is equal to max. Yes, equal to max. Then we'll pop left, pop from here. Since it's a deck, we can pop from both sides. So if you pop 10, we'll have only 1. So 1 will be here. Then we check also for mean. The value is 1. 1 is different from 10, so we don't do anything. We'll move to the next element. So we'll increment left with 1. So left will be here, and right will also be incremented to be in 2. So the window size will be now from 1 to 2. 1 to 2, so it's here. Then we come to 2. 2 is greater than 1, obviously, so we'll pop. And then we'll push 2. In case of 1, it is not, so you just push 2. Because of the mean deck. Then we move on. We'll check the condition if it holds. Its max is 2, mean is 1. 2 minus it holds because it's 1. So we don't do anything, we move. Meaning we increase the R will be incremented by 1, but left will stay the same. So window size, the window will be expanded. This is R. So now it's 4. Then we check again. 4 is greater than 2. We pop 2. Then we push 4. Then we check mean deck. The mean deck we have, the top is 2. 2 is less than 4, so we add. So 4 we added. Then we move on. We check the condition. The max is 4, the mean is 1. 4 minus 1 is 3. 3 is less than 5, so the condition holds. Then we move R, right. The right will be here, pointed to 7. 7 is greater than 4, so then we'll pop from max heap, and then we'll push 7. In case of mean, the top is 4. 4 is less than 7, so we don't pop, we just push 7. We move on again to check the condition. The condition is 6. 6 is greater than 5, so the condition is violated. So if the condition is violated, we'll have to check. You see, in case of max, 7 is different from left because the value of left is 1. So we don't do anything. We check for mean now. Mean deck is 1, so it holds. The left value is 1 and the mean deck value is 1, so you pop 1. Then we increment left with to discard incremented by 1. So it will point at 2. Now left is the 2 and the mean deck is popped. Then you move on. We move the cursor, expand expand it. So it was pointed at 7, now it goes to 2. Right. 2 is less than 7. So we don't do anything, we just push. We push it to the deck, max. The top of this main is 4. So we pop. Because 4 is greater than 2. Then we come at 2. We come at 4. 4 also, the top is 4. 4 is greater than 2. We pop. Then 2. 2 is greater than or equal to. So we don't pop, we just stop there. So the value here, the mean deck will have 2. So the max is 7, the mean is 2. 7 minus 2 is equal to 5. It's less than or equal to 5. So the condition holds. Since the condition holds, we don't need to do anything. And we reach the end of the array. So you stop here. Our answer will be the maximum value, which will be max between max length, which is initially a variable which is 0. So max length will be between and right r minus l plus 1. The value for left is 2. So it's 2. For right is 5. So it's 5 minus 2 plus 1. So the answer is pretty obvious. It's 4. If you check here, you can see the answer is 4. That's how we can solve this problem using sliding window and deck. The time complexity will be O of n, since we are just iterating through all the elements using right, and the space complexity will also be the worst case scenario of n. So it is linear time complexity and linear space complexity. Now let's dive into the coding part. First, we'll have the left pointer for the sliding window. We'll have the max deck, have the, we just put them on the same line. We'll have the min deck, that also is the deck. Then we iterate through, we have the maximum length too, which is equal to 0. And we iterate through using the right pointer in range of length numbers. Then we'll check while max deck and the top element of max deck is less than none. So we keep popping. not pop. We do the same thing. Now you have to add the value, not push. Now, right. We do the same thing for min. Now right it. And min is greater than 5. We'll keep popping. Then we'll add to min deck push number right. Now you have to check. Sorry, you have to check if the condition is hold, meaning if the sliding window is a valid one or not, violate the condition or not. So for that purpose, we'll check y max deck. The first element neat minus min deck is greater than limit, while this is true if max deck equal to left number left, the value of left pointer. Then we just pop left. So pop left will be popping from the left side. The pop on left. If you're asking yourself what the difference between pop and pop left, pop is will remove from the top, but pop left will remove it from the bottom, from the left side. So if this condition is also true for min deck, we also have to pop. So min deck not pop, not left. At the end, so max will be and right minus left plus 1 equal max. Hopefully there is no typos. What? Their collection has not reviewed as push. If it's not pushed, then it has to be bent. And Hopefully the typos are finished. Okay, that's pretty much it. So the time complexity will be of n, and the space complexity of n. Twice n, then O of n. So let's submit and see. Thank you so much, guys. Consistency is the key. See you tomorrow. Please subscribe, share, like, and my goal is to have 150 subscribers by the end of this month. So please, guys, share and subscribe.